So standard position is of a vector is when the initial point, remember that's the tail part where we start. So when the initial point of a vector is at the origin. So you can see in this picture here, here's your initial point at the origin, okay? So if a vector v is in standard position with terminal point AB, then the component form of the vector v is written like this. So whenever you see these type of brackets here, they kind of look like arrows, that means that it's a vector. So there's a difference between having an ordered pair when you use parentheses, and when you find the vector, you have to use these symbols right here. And the magnitude and direction angle theta of a vector given in component form can be found by using the following. So we did this, we did magnitude yesterday, and what formula was that? It was distance formula, right? Well, if I give you a vector, which means if you see these symbols right here and it's a vector, you've kind of already done the distance formula to find this, okay? So for example, this is 0, 0, and this is AB. A minus 0 is A. B minus 0 is B. So therefore, when you find the magnitude, all you do is square root A squared plus B squared. And if you want to find the direction angle, all you do is do tan B over A. So on number one, this means that this is a vector. So if it's a vector and I'm asking you to find me the magnitude, all you do is that's your A, that's your B. So you take 7 squared plus 24 squared. So the magnitude of R is the square root of 7 squared plus 24 squared. I'm going to go ahead and do the math for you. So when you do this, you get square root of 625, which equals 25. So that's your magnitude. If I want to find the direction angle for this vector, I would take the tangent theta of, and it's B over A. Remember, for your vector, first one's A, second one's B. So I'm going to take 24 over 7. So go ahead and get your calculator and let's find the angle. So do you remember what you need to put in your calculator? To find that? You have to use the inverse, so tan to the negative 1. But first of all, since we're using degrees, make sure you put your mode. So get your mode and change it to degrees, or you're not going to get the right answer. Make sure when you click on it, you press enter so degree is flashing. And so you take second tangent, so you have the inverse, tan to the negative first, and then do 24 divided by 7. And you get approximately 73.74 degrees. Now the thing with this is, We need to figure out if this is going to be what quadrant is 724 in? 1, 2, 3, or 4. So if I was to plot, that would be quadrant 1. So everything is positive in quadrant 1. Okay. All right, let's look at, which I don't think this it'll matter. Okay, so let's look at number 3. So to find the magnitude of V vector, we're going to take the square root of 8 squared plus negative 12 squared. Make sure that that's in parentheses if you choose to use your calculator. I'm going to do the math for you. So when you take 8 squared, you get 64. 12 squared is 144. Add those together, you get the square root of 208. Now let's see if we have a perfect square that goes into 208. I'm going to try 16. Oh, 16 and 13. So square root of 16 times square root of 13 is 208. Square root of 16 is 4. This gives me 4 radical 13. The tangent would be negative 12 over 8. So theta, you put that in your calculator, take inverse of tangent, you get 303.69 degrees. Okay, are we good with those 2 examples? All right, let's go ahead and go to the next page. So if I give you 2 points, you should be able to find a vector from the given points. So all you need to do is, if I give you 2 ordered pairs, your vector, and order does matter. You do have to do x2 minus x1. So you have to do the terminal point minus the initial, okay? So when you do that, it's a vector, and make sure you use those brackets, these here, these arrows, those signify that it is a vector. So if we look at number 7, C is 3, 5, D is 6, 3, let's find the vector. So we're going to take 6 minus 3 and 3 minus 5. 6 minus 3 is 3, 3 minus 5 is negative 2. That's your vector of CD. So let's look at number 8, R and B. Oh, I don't know why they put RS. This should be an S, not a B. So we're going to take negative 2 minus 5 and 1 minus 10. That's negative 7, negative 9. That's your vector. All right, so let's put all this together. So on number 9, let's go ahead and find the component form, the magnitude, and then the direction angle, okay? So we have segment MN. Let's go ahead and find our vector. So the vector of MN is 4 minus 2 is 2. 1 minus negative 9 is 10. So it's 2, 10. Now to find my magnitude of MN, all I need to do now is take a squared plus b squared, which 4 plus 100 gives me square root of 104. Which 4 can go into 104? 26 times, so 2 square root of 26 is our magnitude. And then for our direction angle, we just take b divided by a. we could just say the inverse of 5, tangent of 5, and that equals 78.69 degrees. Okay, let's go on down to number 12. Now what if I give you a picture like this? What would you do? If you want to find the vector, what would you do? Can you? All you need is your initial point, which is what? This is your initial point here. So negative 1, 1, 2, 3, 4. And then we need this point here, 1, 2, 3, 4, 1. So to find our vector, this looks like it's vector C, we are going to take 4 minus negative 1, which is 5, and 1 minus 4 is negative 3. Then to find the magnitude, so the magnitude of C is the square root of 5 squared is 25, 3 squared, negative 3 is positive 9, which equals 34. And then for the direction angle, we take B over A, so negative 3 over 5. Which gives us 329.04 degrees. All right, so the last part here says equivalent vectors. So vectors are equivalent if and only if they have the same component form. Use component forms to determine whether A, B, and C, D are equivalent. So let's find the vector of AB. Negative 7 minus negative 3 would give us a negative 4. Negative 2 minus 6 is negative 8. So vector AB is negative 4, negative 8. Vector CD, negative 1 minus 3 is negative 4. Negative 9 minus negative 1 is negative 8. Yes, a vector AB is equivalent to vector CD. All right, let's do the last one here. Vector AB, 0 minus negative 9 is 9. Negative 8 minus negative 2 is negative 6. Vector CD, 4 minus negative 5 is a 9. 8 minus 2 is a positive 6. Are these components the same vectors? No. So therefore, vector AB is not equal to vector CD.